In this video, we're going to talk about game objects. Now, in the last video, I said that a scene is basically a collection of game objects, but what exactly are game objects? Well, we see an example actually of two of them in our scene already. We have our cube and our main camera. Essentially, all a game object is it's the combination of a transform and a list of components. Now, components there's a wide variety of components. You can look at them in the components menu actually and look at all the fun stuff we can attach to game objects. But in this particular example, we see two game objects, each with a unique set of components on them. We'll talk more about the mesh filters, box gliders, and mesh renders later in this video and how to configure them. But we can see that if we move over into our main camera, we have a different list of components like camera, GUI layer, flare layer, and audio listener.
So basically what you're telling me is that the components basically describe what your game object is and does.
Yes.
Okay.
What it is, what it does, what it looks like. So back to our cube, we see that it has a position, rotation, and scale all underneath the transform. And we kind of already talked about what those do by demonstrating the different widgets that we can use to manipulate it. But go ahead and look at the transform right over here as I move this game object around. We see that our position gets updated. If I were to rotate it, our rotation gets updated. And if I were to scale it, our scale gets updated. So the inspector window allows us to modify any component or transform attached to a game object. Now, all game objects must have transforms, even if they are game objects that don't have a visual representation. Often in that case, the transform is essentially ignored because it doesn't do anything. So what I'm going to go ahead and do is I'm going to delete our cube. I'm going to jump into our main camera by clicking on it and hitting F, which allows us to see our game camera, or main camera, sorry. And I'm going to create the first game object that we are going to use for our actual game. To do that, I'm going to go back up to the game object window, create other, and I'm going to create a plane. Now this plane is going to represent the ground of our game. We won't actually be seeing the ground in our game, but it will provide us with collision detection, which I'll talk about very shortly. So I'm going to take a look at what components are a part of the plane. We see that we have a mesh filter, a mesh collider, and a mesh renderer. These three components are what constitutes a physical game object that has a visual representation, such as a mesh. A mesh is basically just a collection of data that represents vertices and triangles that create an object that can be rendered by your computer. So think about it as a model that you would get from Max or Maya or whatever. That's a mesh.
So I understand the mesh collider part, and I understand the renderer part, which tells it what to look like, but what is the mesh filter section? Is that just saying this is a mesh?
Essentially, yes. The mesh filter, its responsibility is simply to point at whatever mesh we want this object to be rendered as. Now, let's go ahead and talk a little bit more about the inspector, because we're going to be spending a whole lot of time in it. If you ever see a little button right here in this little circly doohickey, and click on it, it'll give you a select menu. Now, the select menu will be specific to what kind of object you're sticking into it. So as you see, since our mesh filter has a property called mesh, and with the value of plane, we can click on this guy, and we can select one of the other built-in meshes. Now you'll notice cube, capsule, cylinder, plane, sphere, and quad don't actually exist within our assets of our project. These are built-in meshes that are built into Unity. So I'm going to go back to plane.
So basically, because it's a plane, that recognizes that there's this list of other primitives that Unity already has that fit those same criteria.
Right, it's built into it, so you will always have access to these different meshes, as well as none, which obviously, well, makes it disappear. All right, so I'm going to go back to plane. So again, the plane allows us to see the game object as a plane. Now we have the mesh collider, and for our example, that's going to be the most important component. What that does is the mesh collider, it describes to Unity how collision detection is handled. So a collider is a way for Unity to know how to calculate if this object ever intersects another object. And obviously that's going to be very important for our missiles to be able to, hit the ground or hit our cities or hit our silos and so on. We'll talk more about the actual properties of Mesh Collider later in the series, but I just wanted to point out that's what this is. There are also a variety of different other colliders within Unity, such as the box collider or the sphere collider, which are a little bit more efficient if you're willing to sacrifice some granularity. The mesh collider in this case takes in a mesh, just like the mesh filter, and calculates collision based off the vertices in that mesh. So in theory, I could say that this has the mesh collider of a sphere. As you see, the green little wireframe is the mesh that's used on the mesh collider, and now only objects that hit that green part will be considered to be collided against this object. Obviously, what we would want to do is use a plane, which is the same that we're rendering.
So this is an easier way to get the collision you want, but it's going to be a little more costly.
Yes, with the mesh collider, it's a little bit more costly because it has to calculate the vertices on the mesh itself in order to provide collision. What you would typically do in a game where you want complex collision, such as a first-person shooter where hitting an arm has a different effect than hitting a person in the head, what you would do is you would create a low-poly version of the mesh that you render and use that as the mesh collider mesh, so that the collision is performing fewer computations than before.
Gotcha.
Or you could just set it to the same thing, but that'll be slower. Okay, next up we have a mesh renderer. Now the mesh renderer is all about how our object looks inside of the world. I want to point out something really quick about components. Most components can be added or enabled or disabled, and that's with this little checkbox. I want to show you guys what happens if I disable the mesh renderer. As you see, our mesh is no longer visible. We see the mesh collider visualization because the green is from the mesh collider, but we no longer see the mesh being rendered. Now the mesh renderer, the most important property of it is called the material. And we'll be talking very shortly about materials when we go ahead and create our own. But for now, I'm just going to leave that as the default. Okay, so I want to go ahead and do an exercise. This isn't actually related so much to the game, but I think it'll really solidify people's understanding of what game objects are. And that is, I want to create a game object that has no components, and I want to effectively turn it into this plane. So to do that, I'm going to go up here to Game Object, and I'm going to say Create Empty. Now this is something we are going to frequently be doing to create game objects that just have code attached to it, rather than having other things such as colliders or renderers or whatever. What I'm going to do is I'm going to move this game object up here so that when we start adding visual components to it, we can see it side by side with our plane that we constructed. Now you see that we have a transform, but we don't actually have any visual representation of the game object because the game object has nothing but a transform. I also want to point out that we created the plane again through the game object create other plane, which essentially just created a pre-configured game object for us.
Now this would have like code and stuff attached to it. Would you also do this for like your audio file scripts?
Yes. For audio files, you would also need to attach them to a component. Okay, so that's our empty game object. Right now has no components. And for this exercise, I do want people to follow along with this because adding components is going to be something you do quite frequently. Now, there are two ways to add a component. The most obvious way is this really big Add Component button.
Could that be it?
Yeah. I think maybe it could. And the second way is through this slightly more obnoxious drop-down menu. Drop-down menu is nice because you can see a list of things, but I like the button. So the first thing I'm going to do is I'm going to add a mesh filter. So I'm going to click on Add Component, and I'm going to type in mesh filter. And I get a mesh filter component. I'm going to add it on, and now we have a mesh filter component. So remember, mesh filter is used to describe to this game object that it has a mesh attached to it. So I'm going to click on this little bullseye doohickey guy here, and I'm going to select one of our existing prefabs, one of them being plane, that come with Unity. So now that this mesh has a filter called plane, we still see no visual representation of the mesh. And that's why we don't have a... Steve?
Well, you don't have a renderer.
Exactly. Now I'm going to go ahead and attach a mesh renderer to my game object. The mesh renderer will pick up on the fact that we have this mesh filter and use the mesh filter to render a mesh, which is probably why it's called mesh renderer.
Seems reasonable.
So now what we see is our plane has appeared. Almost just like the existing plane that we had before. However, it's this really, really disgusting color. It's actually this really, really disgusting color for a reason. Unity really wanted to... it's basically describing to us an error, a rendering error, and it wants us to address this, otherwise our retinas will be burnt.
So in CryEngine, if I just bring in a mesh, I get this huge bright red thing that says replace me because there's no textures.
Yeah.
It's kind of like that.
Exactly. And the reason that this mesh renderer is doing this is because our mesh renderer doesn't actually know how to render our mesh. That's because it doesn't have any materials on it. Now, a material inside of Unity is nothing more than a way to describe how something looks. A material is typically the combination of a shader and a list of parameters for that shader. So what I'm going to do is we're going to talk a little bit more about materials in a moment here, but for now I'm going to click this little circly thing and I'm going to select Default Diffuse. Default Diffuse is a built-in shader inside of Unity, and I'm going to select that. So now we have given our renderer an element called Default Diffuse, which describes to the renderer that it should render whatever mesh we have in our mesh filter as a gray diffuse thing.
Flat gray color.
Basically, yeah. Again, we'll talk about materials very shortly once we actually create one, but we're still missing one important thing with our ground. Now, you remember how I said that our ground isn't actually going to be visible in the game, as you saw in the first video, but we still need it for our collision. At the moment, every object that hits our plane will not notify any scripts attached to it that it has hit that plane. That's because Unity isn't performing any collision detection on it. That may be desirable for things that you can't physically collide with, because then it makes Unity have to do fewer computations. But for things that things will collide with, it's very important.
So we got to search for a collider.
Yep. So I'm just going to type in collider, and we can see a variety of the different colliders we have available to us. We have box, capsule, mesh, sphere, terrain, wheel, and world particle. I'm going to use the mesh collider, and by doing that, we now get a mesh collider that I can go ahead and configure in the same way that this mesh collider is configured. So I'm going to select its mesh as plane, which actually it did that by default. Yeah. When I added the mesh collider, it looked at the mesh filter and grabbed the same mesh. Okay, so the entire point of this exercise was to solidify in everybody that game objects are nothing more than a combination, transform, and a list of components, and that I can effectively make one game object behave like another by setting up all the same components and configuring them in the same way. You'll also notice that the orders of these components are a little bit different, but that's irrelevant in this case.
Now, on the mesh collider, I see the first thing is trigger. Does that have to be checked for a collider?
No.
Okay.
There's a difference between collision and triggers, which unfortunately is going to require a video of its own, because it is it gets a little esoteric.
All right, but it's okay for it not to be checked, depending on what you're doing.
Okay, so now we have two game objects that are virtually indistinguishable from each other because we configured them as such. So what I'm going to go ahead and do now is I'm going to take this plane that we created from the game object dropdown, I'm going to delete it. To do that, I'm just going to select the game object and hit the delete key. There's not a whole lot to say about that.
Yeah, it's pretty standard.
Yeah. The next thing I'm going to do is I'm going to talk a little bit about naming. Now, every game object in our scene has a name field, and that name field can be anything we want. You typically want to name things in a way that makes sense and make it easy for you to see them in your hierarchy. So I'm going to go ahead and name this ground.
Now, are there other ways for us to change those names?
Yep. There are two other ways. The first way is a slow double click on the name. There we go. In the hierarchy. That's very similar to how you would rename folders in Windows. In addition, my favorite is F2. F2 is a standard renaming shortcut in most programs and operating systems.
That's funny, I never knew that.
Well, okay.
I know, go ahead, say it.
Well, it is. No, I'm not going to say anything. Okay, so now that we have our game object named ground, I'm going to cheat here and throw in some values that I actually know beforehand for its transform. And that is, our ground will be located at 0, -8, 27. Its rotation will be 0, 0, 0, and its scale will be 15, 7, 7. Now, the way I came up with those numbers is just through, trial and error. There's nothing secret about it. I'm also going to, I'm not going to configure our camera quite yet. We'll talk a little bit more about that in the upcoming videos. So now
I do see that the picture of the camera always looks to be pointing sideways, so it's important to click on it to see where you're actually looking.
How do you mean?
Like right now, the camera looks like it's pointing to the right. The actual white picture of the camera. But if you click on it, then you get the box.
Oh, shows. Right, yeah. Yeah.
Because if I just saw that, I'd be like, oh, my camera's pointed off that way.
Right. The camera preview is very important. In addition, if you recall from the last video, the game view will always show you what the scene looks like through the eyes of your main camera.
Perfect.
So you can always switch over to this to view that.
Awesome.
Okay. So the last thing I want to go ahead and do is talk a little bit about materials. Now, we'll see a lot of really practical examples of building materials in the later videos, as it's a very, important thing to do in a 3D video game. But I just want to run down the basic steps for you guys. First thing I'm going to do is I'm going to create a folder in my project. Remember, this is just a view into our assets folder on our hard drive. And I'm going to create a folder by hitting create and going to folder. This new folder I'm going to rename to materials. Once I've done that, I'll select the folder materials, hit create, and really surprisingly go up to material and click on that.
Now, when you're creating this in your projects tabs here, that is actually creating that folder.
Yes.
In your real folder.
Yep, I can show that. I'm going to go ahead and name this ground material. And I can show that if I open up my Windows Explorer and jump into assets, we now have a folder called materials with groundmaterial.mat inside of it.
Excellent. So that's just a good way to not have to step away from the UI you're working with.
Yep. So here's our material, ground material. And our ground material, I'm just going to set up as a basic brown color. To do that, I'll select on it and open up my inspector. Now, if your material is collapsed and you see this, don't get frustrated. I remember the first time that I saw that. I ended up going to Google to figure out how to get my materials back.
That would freak me out.
Yeah, it was really obnoxious, but all you have to do is just click on it, and it'll expand your options. So like I said earlier, a material is a combination of two things, a shader and the parameters that go into that shader. Now, a shader is a program. It's actually code that runs on your video card to make an object look a particular way. Effects such as reflection, diffraction, diffuse, specular, bump mapping, parallax, self-illumination, all this stuff is handled by those little programs called shaders that run on your GPU on one of its very, very many little processors that it has on it. A diffuse shader is one of the simplest shaders. All that does is it takes in a light source and kind of shades our object based off the light source and doesn't do anything special with that.
Basically, it just says stuff is this color.
Essentially. The default Unity Diffuse shader also allows us to put in a texture as well, although we won't be using that just yet. Now, you can write your own shaders in Unity, and there's a really big, awesome, environment that you can use to write shaders that will run on all sorts of devices. However, for this video series, we can get by very easily by using the myriad of built-in shaders. So, like I said, the shader is the program, but the shader program, has parameters that we can pass into it. For example, the color, or in this case, the texture as well, which we won't be using. So for this color, I'm going to just click on that little color doohickey guy, go into some sort of brown, and click off. Now our ground material has a diffuse shader with a brown, that's not really that brown.
More orange in it. There we go.
There we go. I would fail color theory. So there's our ground material, and it's just the diffuse shader with the brown color piped into it, and that's it. So how do we go about applying this ground material to our mesh renderer? Well, there are a couple different ways. The most straightforward way is to click on our game object that we want to attach the material to, go to our mesh renderer, open up our materials list, and select, so see here element 0 is our default diffuse. I can use this little circly doohickey to open this up, and now we see our ground material in this list, because this list will include things that are inside of our project folder.
Now, I know Unity has a bunch of different materials built in with it. How come we're not seeing any of those in that little list there?
Well, it's because the materials that come with Unity are provided through what are called packages.
Okay.
And the packages can be included when we create our project or later down the line. We are actually going to be using some standard packages later in this video series.
But you never loaded any, and that's why we don't see it here now.
Right.
Gotcha.
Okay, so there's one other way we can, a very more common way to add a material to a game object, and the way that I will commonly use. I'm going to go back to default diffuse and click off, and I'll show a different way to do this. Whether or not we have this game object selected, so I can demonstrate it with it not selected, I can actually click and drag from our project onto our game object.
Bam! Look at that.
Yeah. That's pretty cool. So we just drop it, and we can verify that our ground material was indeed selected. In fact, by clicking on it, it gets highlighted inside of our project folder.
Oh, that's a neat feature.
Mm-hmm. Okay, so that is our basic materials that we've added to a game object that we effectively constructed from scratch, giving it our own filter, render, and collider, and then building our own material out of it. So I'm going to go ahead and point out one last incredibly important thing that you need to know about working with Unity, and that is how to play your game. Now,
Okay.
well, the reason this is important is it's something that people get tripped up on all the time. The first thing is I'm going to go ahead and save by Control-S to save my scene out. You should do that often. And then I'm going to hit this play button. Now this play button executes the game and has it start running. When the game is playing, all of our scripts and all of our effects and all of our everything will be ran.
And do what they do.
Right, exactly. In addition, we can also go back to the scene view and watch the game objects fly around inside of the scene view. We can also go into our game objects and actually modify them as much as we want. In fact, if I had the game view and the scene view visible at the same time, we can see that I'm actually modifying this game object.
Now, I've never really used Unity, but that brings up something I've heard of. Is this the thing where if you're in this mode and you change things, they're not going to save like that?
Exactly. If I go ahead and stop playing, watch what happens. It reverts back to how it was before I started playing.
So if you change the location of an object or something like that, it's going to snap back to where it was.
Yep. Now, that is something that will frustrate people, and people will get tripped up on, and it's happened to me. And It's just something for you to keep in mind.
Okay.
Okay, before I finish this video, we'll notice here that our scene is actually all black. And why do you think that is?
We don't have a light in there.
No, we don't. Lighting is actually very straightforward inside of Unity. Fortunately, it's one of the things that it gives us by default. So let's do a quick rundown over the different lights, because we're not going to be spending a whole lot of time playing with lighting effects in this video series, but we do need at least one. If I go into Game Object and hit Create Other, we'll see that we have a directional light, a point light, a spotlight, and an area light. Let's just show a quick example of these first three. The simplest one, in my opinion, is the point light. If I create that and frame up on it, we see that we now have a light in our scene. You'll also notice that the default lighting of Unity has disappeared, and now our scene appears black as it did in the game view. That's because we actually have a light in our scene.
All right, and that light is like a light bulb.
Exactly. We can play around with its different settings. We can change its intensity. We can change its color. We can change its range. We can change its range either by modifying this parameter, or we can actually click on these little guys right here and move them in and out. So that's kind of neat.
Oh, that's very handy.
So yeah, so this is just basically a light bulb, and you can have as many of them in your scene as you want. If, for example, I was to move this light bulb somewhere we can see in the game view when I actually hit play that we have the light. The next most common one, well, depending on what you're doing, is going to be a spotlight. Now, the spotlight behaves like a spotlight.
Yeah. I think of it as the horror game light.
Yeah. So with the spotlight, we have two things we can change, really, besides things like intensity and so on. And that is the radius of the spotlight. Let me bump up the intensity so we can see this effect a little bit better. We can change the radius of the spotlight, or the spot angle, sorry. And we can also change the range of the spotlight.
Okay, so that kind of controls the fall off of the light.
Right. The last light, and the light we will be using, is going to be called the directional light. Now, the directional light, I'm going to go ahead and clear it out to a position 0, 0, 0 with a rotation of 0, 0, 0, so that we can take a look at an interesting property of the directional light. If you look, it looks like these little beam thingies, and they're all parallel. Now, as we know, rays of light are almost never parallel, but if you have an object sufficiently far away from a light source, they appear to be parallel. An example of that would be our sun.
Yeah, so this is mimicking daylight.
Exactly. And the only thing out of the transform that matters is going to be the rotation. It doesn't matter where this object is positioned because it's directional. So
Unity's treating it like it's 50 million miles away, like our sun is.
Yep. So that's where the calculation comes from. Now, again, like I said, in the real world, rays of light are almost never parallel, but as an approximation of our sun, they can be thought of as such. So as you see, as I rotate it, the light hits that game object in a different way. I can also just prove to you guys that the location doesn't matter by just moving this all the way down, all the way down, all the way down. And you see it doesn't actually impact the way that the shading happens. So now if I were to, you see, you look at this.
Oh, yeah, we're in trouble. We've been in play mode. None of this is going to work.
Yep, so all of this stuff that I just did was not going to be saved. Anyway, wow. You know, it's funny. I haven't actually made this mistake for a while now. I used to a lot when I started. It's funny that, like, the first time I would make this mistake is like right after telling people not to do this. But, yeah, okay, I'm going to stop playing, and I'm going to jump back over here, and as you see, this original point light that we created a long time ago is now there. I'm going to delete him, go to Game Object, Create Other, Directional Light, and I'm going to zero out its rotation. And then I'm going to rotate it a little bit like that.
So essentially, the other lights, you can think of the light as coming from the widget, but in this case, the light is coming from that direction, irregardless of how you place that widget.
Yes. Okay, so I'm going to save out my scene, hit play, and we now see a lit ground. I know it's not very exciting for you guys, but this has been a very important introduction to game objects because we are going to be spending the rest of our time building game objects by configuring them with different sets of components.
No, this is good. I learned some cool shortcuts. It's awesome.
Yeah, so we'll see you guys in a bit.